teach you about the ligands. Ligands is studied under the. I am going to teach you about the ligands. Ligands are present in the coordination compound, as you see here, in diamine sulfato nickel 4 chloride. Here 4 is the oxidation state of nickel. NH3 is a ligand, SO4 sulfate ion is a ligand. NH3 is neutral ligand and SO4 is negative ion ligand. So the ligand are those species which are coordinated with central metal atom or central metal ion in the complex entity. In the complex entity, you see NH3 and SO4. Both are ligands, but NH3 and SO4 both are coordinated, means they are combined with nickel metal atom or ion with coordinate bond. So ligands are those species which are combined with central metal atom or ion by coordinate bond. According to the number of donor atoms, coordination between central metal atom and ligands is due to donation of one pair electron by the ligand atom or molecule to the central metal atom. In the NH3 and SO4, nitrogen atom is a donor atom in NH3, and in sulfate ion, oxygen atom is a donor atom. So, according to the number of donor atoms present in the ligand, ligands are of many types and known one by one as first, monodentate ligand. Is only one donor atom is present. Chloride ion, bromide ion, iodide ion, cyanide ion, H2O, etc. Second, bidentate ion is two donor atoms are present at carboxylato ion. Out of 4 oxygen atoms, 2 oxygen atoms are donor atoms, which are coordinated with central metal atom or central metal ion. In similar way, sulfate ion in this also 2 oxygen atoms are present as donor atoms. In ethylene diamine, this is the neutral ligand because it has no charge, and in this the donor atom is the nitrogen atom which has lone pair electrons on it. Ethylene diamine. Third is tridentate ion. In this, 3 donor atoms are present. Example, triamine. In these 3 nitrogen atoms are donor atoms. 1 nitrogen atom, 2nd nitrogen atom, and 3rd nitrogen atom. Because there are 2 ethylene groups, CH2, CH2, diethylene, and 3 amino group, diethylene, triamine. Tetradentate ligand. As name implies, there are 4 donor atoms. Example, triethylene, tetraamine. Triethylene, tetraamine. CH2, NH, CH2, NH, CH2, fourth point is the tetradentate ligand. There are 4 donor atoms. Example, triethylene, tetraamine. In this, 4 donor atoms are nitrogen atoms 1, 2, 3, 4, and 3 ethylene groups CH2, 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 CH2 and CH2, CH2. In this way, in tetradentate ligand, there are 4 donor atoms here as nitrogen donor atoms. Next point is pentadentate ligands. There are 5 donor atoms. Pentadentate ligand, there are 5 donor atoms. Example, diamine triacetate ion. In this, there are 3 oxygen atoms are donor atoms and 2 nitrogen atoms are donor atoms. Total, there are 5 donor atoms in the pentadentate ligand. As example, ethylene diamine triacetate ion. Hexadentate ligand. In this, there are 6 donor atoms. Example, EDTA means ethylene diamine tetraacetate ion. As CH2 and CH2C double O acetate ion, CH2C double O acetate ion. In similar way, CH2C double O acetate ion and CH2C double O acetate ion. In this way, we see that there are 4 donor atoms of oxygen and 2 donor atoms of nitrogen. Hence, ethylene diamine tetraacetate ion, here is CH2 ethylene. There are 2 nitrogen atoms here, amino group, and with each amino group, 2 acetate groups are joined. So on whole, there are 4 acetate groups. So tetraacetate ion, double nitrogen is diamine and one ethylene group is ethylene. Ethylene diamine tetraacetate ion. Some ligands known as ambidentate ligands. Such ligands in which two donor atoms or more than two donor atoms are present in the complex ligand, but only one donor atom is coordinated with central metal atom or central metal ion. Such a ligand is known as ambidentate ligand, as cyanide and nitrite ion. In these two ligands, both are bidentate, but at one time carbon is coordinated with central metal ion or metal ICN, and in other time nitrogen is coordinated with central metal atom or ion. So such ligands in which only one donor atom attached to the central metal atom or ion, although they have more than two donor atoms, are known as ambidentate ligands. There is another identity is flaxidentate ligand. It is the polydentate ligands, but all donor atoms are not utilized in coordination with central metal atom or ion, and such polydentate ligands are called flaxidentate ligand. The ligands having more than two donor atoms are known as flaxidentate ligands or polydentate ligands. So in the polydentate ligands, another species arises as flaxidentate ligand, in which donor atoms may be more, but out of them certain donor atoms are coordinated with central metal atom, as EDTA is hexadentate ligands, but in some coordinate compounds only 4 donor atoms or 5 donor atoms of EDTA are utilized or coordinated with central metal atom or ion, and such EDTA as ligand is known as flaxidentate ligand.